Hello guys, welcome to the next video on Java thread tutorial for beginners. In this video we will see what does join keyword do in Java threads and how to use join keywords in Java. So let's get started. I'm going to give you an example and I will show you how you can use this join keyword. So I have this blank project with a blank main method, and first of all what I'm going to do is I'm going to define a simple thread object. So I'm going to call thread t1 is equal to new thread, and inside this constructor I'm going to implement this runnable here, and then I'm going to call the run overload here. So implement the method. Let me close this thread constructor with semicolon and this bracket, and inside this run method what I want to do is I want to once again create a for loop, and this time I want to iterate this for loop to around 10,000 for this example. Okay, and now what I want to do is I want to create a private variable which will be a static one and which will be an integer. Okay, and I will name it as count, and I will initialize this count as 0. Okay, and now what I want to do is I want to increase this value of count inside this for loop by 1 every time this for loop iterates. Okay, now similarly I will create a second thread object. This is our first thread object, which is t1. I'm going to copy this and I'm going to paste it just below this, and I'm going to name it as t2. Okay, so we have two thread object, t1 and t2, and I want to start thread 1 and thread 2 now. So I will just call t1 dot start and t2 dot start. Okay, so what this will do is it's going to start the thread 1 and then thread 2, and then what I want to do is I want to print the value of count now. So sys out, and I want to print the value of count. Okay, and if you want you can just write. So what I want to do here, I want to increase the value of count, which is this variable, and I want to increase this value in both the threads. So both the threads will share this count variable and increase its value when we iterate over this loop. Okay, so this count variable is accessed from thread 1 also and thread 2 also, and what we expect, we want to print the value of count at the end of the threads 1 and thread 2. Now let's see what happens when we run this program. So let's run this program and let's see what will be the output. So we will run this, and here we can see the value of count which is printed here is 0. Now the reason for this is when we create thread 1 and thread 2, and when we call the start method on this thread 1 and thread 2, this returns immediately when t1.start is called, and then this returns immediately after t2 start is called, and then this will print the value. And after printing the value, this thread t1 and t2 will start. So basically this thread 1 and thread 2 will not wait to end themselves before printing the value of count. That's why this is printing count is equal to 0. Why? Because thread 1 will start, thread 2 will start, and it will before looping through this loop, it will print the value of count, because this start will not wait until this thread 1 is dead and thread 2 is dead, and it will print the value of count before the end of these two threads. That's why we can see the value of count is equal to 0. Okay, now to solve this problem, what we can do is we can use a keyword called join. Okay, so what we are going to do, we are going to use the keyword called join on T1 and T2. So let's introduce this join keyword, join, and this joint throws. So we need to enclose this join inside our try catch block. So when you click this bulb, you see that add throw declaration or surround it by try catch. So we will surround it with try catch block, and inside this try catch block we will also call t2 dot join. Okay, so what does this join keyword do here? Okay, so let's see what this is doing. So in Java, this join method can be used to pause the current thread execution until and unless the specified thread is dead. So when we call this join will allow this thread to be dead or to be finished until and unless this second thread is called and finished. Okay, and once these two threads are finished, and then only we will print this value of count here. Okay, so this join waits for the thread to complete and then only allows the execution of other code after that. Okay, so now let's run this program and let's see what happens. So I'm going to save this and run this, and now it's printing the value of count around 13,000 something. Okay, let's run this once again, 11,000 something, right? Run it once again, 10,000 something. Okay, so this at this point it's increasing the value of count by 1, and we will expect that this count should reach at least 20,000 because we are iterating 10,000 in one thread and 10,000 in other thread, right? So we will expect the value of count should be 20,000, but it's not 20,000. When we print this value, it's around 10,000 and it's random, 9,900 and 18,350. So why this is happening now? So okay, this join will wait for the thread to complete, but this operation we are doing on this count, which is increasing the value of count by 1, is really slow in the terms of computer execution. So for example, this count is something like this. Okay, so it takes the value of count and then increases the value of count by 1 and then places in the same variable count. So in the computer terms, it's a long process. And for example, both the thread, if they want to access this variable at the same time, one will win and it will increase the value of count by 1. Okay, so in this way both the threads are trying to access the value of count and increase it, and that's why this count value is not reaching up to 20,000. Now to solve this, what we can do is we can use a keyword called synchronized. So what we will do now is we can create a method, for example public static void, and we can name it as inc count to increment count. Okay, and what we can do inside this method is we can increase the value of count by 1 as we were doing inside this loop. Okay, and we can call this inc count inside our for loop instead of this count increment, like this. Okay, in here and in here. So basically this method is not doing anything, but when we add a keyword called synchronized here, so let's add a keyword called synchronized. Let's see what happens when we run the program. So run the program and it prints 20,002. Now it's printing 20,002 because in our condition I should be less than or equal to 10,000. So when we do I should be less than 10,000 here and here, and we will save the program and run it once again, it prints 20,000, and we can run this program many times and it will always print the value of count is equal to 20,000. Now what this synchronized keyword is doing here. Now in Java, every object have its intrinsic lock, and what this lock does is it locks the access of a certain variable when this lock is called, until and unless it does its operation on this variable, and it can be only accessed by one thread only. So this lock or this intrinsic lock can be called only by one thread at a time. And if two threads wants to access one variable which is locked, then one thread has to wait for the acquiring of the lock, and other thread will acquire the lock and do its operation. So the synchronize calls this lock in background, so this count can be accessed only once by one thread at a time. Okay, so one thread acquires it and increase it, and then other threads acquires it and increase it. Okay, so in this way this synchronize solves the problem of thread interleaving in a way that it allows this variable to lock so that it can do its operation, and then allows the other threads to do its operation. So in this way the keyword join and keyword synchronized works in threads in Java. So I hope you have enjoyed this video. Please rate, comment and subscribe, and bye for now.